questions 21 through 25 on the 2006 grade 11 Fermat math contest. For how many integers n with 2 less than or equal to n less than or equal to 80 is n minus 1 times n plus 1 over 8 equal to an integer? Well, there's got to be some sort of a system, right, that allows us to do this quickly without having to write out all the numbers from 2 to 80 and then look at each single possible scenario. Now, one thing I hope you can quickly recognize is that n minus 1 times n plus 1, without the 8, just look at these three, is 3 consecutive numbers. I hope you can very quickly see that. And because there are 3 consecutive numbers, we can look at them in terms of odd or even. So the first scenario is when you've got even, odd, even, like that. Since they are consecutive, right? For example, 2, 3, 4, 5, 6, 7, right? They're consecutive. You can't have even, odd, odd. If you look at these numbers, it's always even number, then odd, then even, then odd, then even, and so on, right? It alternates because they're consecutive. So the first scenario is basically a scenario of even, odd, even. So for example, you can have 4, 5, 6, right? 3 consecutive integers, even, odd, even. Now, if this is the case, is it going to be divisible by 8? Because that is our criteria, divisible by 8. It must be in order to get an integer value. Yes or no? Will it be divisible by 8? Well, think about it, right? Both of these even numbers are divisible by 2. That's what it means to be even. The odd number is not going to help us in any way. It's useless. Now, 2 times 2 is 4. It's not 8. So you think, okay, well, that's no good. But the good news is that one of these numbers, either this one or this one, will always be divisible by 4. In this case, it's the first one. And because it's divisible by 4, it's really 2 times 2. And therefore, you've got 2, 2, and 2. If you multiply them, you will get 8, and therefore it will definitely be divisible by 8. Let's try another scenario, but with the same pattern, even, odd, even, because I want you to be convinced of this. Let's try anything really. 12, 13, 14. Okay, actually, you know what? Let's try one where it's a multiple of 4 on the other side. So, for example, 14, 15, 16. Here we go. This is even, it's a multiple of 2. This is even, it's a multiple of 2. This is odd, so it's not a multiple of 2. So I've got 2 and 2. 2 times 2 is 4. But I want 8. Well, as previously stated, at least one of these will always be a multiple of 4. And in this case, it's this guy right here. That is definitely a multiple of 4. So we're going to be able to get 2 times 2 out of it. So now we've got 2, 2, and 2. There you go. And if you keep doing this, you will see always in this kind of even, odd, even scenario that you will always be able to get 2 times 2 times 2 out of those numbers, no matter what. So, how many times from 2 to 80 do we have even, odd, even? Well, it's basically half of the time. So, that's where you have to figure this out a little bit. You're going to have about... So, pause for a minute. Think about how many of these scenarios do we have? Well, if you're not sure, just make a little list. You don't have to make the full list, but just get an idea. The first one, of course, even, odd, even, would be 2, 3, 4. The next one would be 4, 5, 6. The next one would be 6, 7, 8, like that. All the way up to the very last one. For even, odd, even would be 78, 79, 80. And how many of these are there? 39. Okay, and the answer choices help you a little bit, I think. So is the answer 39? Well, before you circle that and move on, give this question a little bit more time. The answer is not 39. Why? Because there's a few more scenarios. Okay? And the good news is that the remaining scenarios are relatively easy to explain. The next scenario is if you have odd, even, odd. Okay? That's the only other scenario possible. And for example, odd, even, odd would be like anything really, like 7, 8, 9, or 45, 46, 47, like that, right? Any kind of scenario where you have it odd, even, and odd with consecutive integers. Now, in this scenario, again, I have to get a product that's divisible by 8. Okay, let's see if I can do that. When my numbers are odd, even, odd, the odd number is not going to give me a multiple of 2 or 4 or 8, so it's useless. Similarly, the third or the next odd number also doesn't give me anything. It's not divisible by 2, right? That's what it means to be odd. But the middle number, even, it has to now take the entire responsibility of being divisible by 8. So it has to be divisible by 8 itself. So in this case, it is. So 7, 8, 9 also fits the criteria of our question. So basically it means that anytime this middle even number is a multiple of 8, this criteria will be fulfilled. So how many multiples of 8 are there between 2 and 80? Well, 8, 16, 24, 32, 40, 48, 56, 64, and 72, and 80 itself. So how many is that? 1, 2, 3, 4, 5, 10. So I've got an additional 10 scenarios. So I had 39 up there, 10, and the sum of that is the total number of scenarios in which this expression will be divisible by 8. So 39 plus 10 is 49, and therefore number 21, the answer is E. Quincy and Celine have to move 16 boxes and 10 small boxes and 10 large boxes. The chart indicates the time that each person takes to move each type of box. They start moving the boxes at 9 a.m. The earliest time at which they can be finished moving all the boxes is. So we will have to do a little bit of casework here. Quincy and Celine. Celine and Quincy. So since Celine takes 2 minutes, only 2 minutes, I'm going to give her all the small boxes, okay? So that will mean it will take her 32 minutes. And then while Celine is moving those small boxes, Quincy has to do some work, so I'm going to give him the large boxes. But how many? Well, let's try to match up the times. Well, it takes him 5 minutes to move one large box, so let's give him 6 large boxes. That would mean it would take 6 times 5, which is 30 minutes. All right, so far so good. We want to match up these times. I think that will be the best way of moving with this question. Now, how many boxes do we have left? All the small boxes have been moved, but we've got 4 large boxes remaining. So I'm going to distribute them evenly. I'm going to give 2 to Celine and 2 to Quincy. To move the first large box, Celine will have 6 minutes that she needs. So this brings me up to a total of 38. To move the next one, another 6 minutes. So now we're up to 44 minutes. Now if we turn our attention to Quincy, for one box, it's 5 minutes for him. So he will first have a cumulative total of 35 for that first box, and then the second box will bring his cumulative time up to 40 minutes. Now they're working simultaneously, by the way. So at what time are they now done? Well, 9:44 a.m. Now, is this the earliest time they can be finished? Well, I don't know. Let's see. That's definitely a candidate. Let's see if we can make a scenario where they can finish quicker. So here we go, Celine and Quincy. I'm going to now slightly change this. 15 small boxes this time. And let's see if this gives me a quicker result. For 15 small boxes, 2 minutes per small box, 30 minutes it will take Celine. Now while Celine is moving, Quincy needs to do his job. So I want these times to match up. And I can do that perfectly by giving him 6 large boxes. 6 boxes at 5 minutes each gives him 30 minutes of time. And there you go. Perfectly matched. And that hopefully will give us a quicker overall time. Now, how many boxes do I have left? I've got 1 small box remaining, and I've got 4 large boxes remaining. So I'm going to first give those 4 evenly to both Quincy and Celine. So to move these 2, it's 6 minutes each. So it'll be 36 minutes for the first one, and then another 6 minutes brings me up to 42. So then Celine is done with those 2 large. Now for Quincy, it's 5 minutes, so it brings his total up to 35 for the first large, and then another 5 minutes. Now he's up to 40 minutes. Now remember, there's 1 small box remaining because this is only 15. So 1 small box, I'm going to give that to Quincy. He takes 3 minutes to move 1 small box, so that means he'll move up to 43 minutes. So what time is it now? It's 9:43 a.m. So there you go. With this scenario, I got a slightly quicker time, 9:43. Now, can I get 9:42 or 9:41? And with trial and error experimentation, you'll see that that's not possible. No matter what scenario you use, 9:43 is the quickest this whole job can be finished. So the answer to number 22 is C. Rectangle TEHF has dimensions 15 by 30, as shown. Tom the cat begins at T, and Jerry the mouse begins at J, the midpoint of TE. Jerry runs at 3 meters per second in a straight line towards H. Tom starts at the same time as Jerry, running at 5 meters per second in a straight line, arrives at point C at the same time as Jerry. The time in seconds that it takes Tom to catch Jerry is closest to. So, several ways of approaching this. I'll do it in the way I find most comfortable. First thing we're going to do is drop a perpendicular from C down to the bottom like that. And then I'll draw 1 line from C to HE like that. And I think that should be it for this question in terms of lines. Now I'm going to start labeling. So they tell you that J is the midpoint of TE, right? So that means this TJ is 15. And from here to here, this little guy right there, I'm going to call that X because I don't know what that is. And then this little guy from there to there, I'll call that Y. Okay, so from J to that point is going to be 15 minus X. And very similarly, that distance from C all the way down is going to be 15 minus Y. All right? And that is basically, I think, all I need to label. The only other things are that Tom is his name. He runs at 5 meters per second, and Jerry runs at 3 meters per second. And since from here to here is X, from here to here is also X. So just put that X right there. All right, let's proceed with this question. First thing that I'm sure you probably noticed is we have a couple of Pythagorean theorem relationships. So the first one, of course, is this triangle right here. And the second one is this bigger triangle right there. So the first one we've got, let's see here, 15 minus x squared plus 15 minus y squared is equal to this distance JC. Okay, now JC is really the distance that Jerry travels. So I'll call that distance of Jerry. Okay, just make it simple like that. The distance that Jerry travels on his path from J to C, or J to H. Now, very similarly, the next triangle, Pythagorean relationship, looks like 30 minus x all squared plus 15 minus y all squared is equal to TC. But TC is really just the distance that Tom travels. So I'll call that DT. And remember, don't forget to square these guys. All right, so far so good. No confusion, right? Okay. Now, next we have to understand the fact that both of them meet at C. Correct? Tom gets to C, Jerry gets to C, and that's where they meet. So that means that the amount of time that it takes Tom to go from there to there is the same as the amount of time it takes Jerry to go from J to C. And that's why they meet. So therefore, the time for Tom, TT, is equal to the time for Jerry. All right? Now remember our formula? Speed is equal to distance over time, right? And therefore, time is equal to distance over speed. So this will be distance for Tom over speed of Tom, and this is going to be distance of Jerry over the speed of Jerry. All right? Now the distance we just calculated right here, but the speed we know is fairly straightforward. That's just a number. The speed of Tom is 5, so dt over 5. The speed of Jerry is 3, so dj over 3. There you go. Cross multiply and you get 3 dt is equal to 5 dj. And since these are squares, I'm going to square these guys. And if I do, I'll get 9 dt squared is equal to 25 dj squared, like that. And there you go. dt, which is right here, is this guy. dj, which is right there, is this guy. But one thing you'll notice is that you've got x's and y's in there, and I only want one variable. Is there any way to do that? And the answer is definitely. How? Well, similar triangles right here. This little triangle is similar to this big triangle, and that helps us tremendously. How? Well, y over x is equal to this full length, which is 15, over this full length, which is also 15. And therefore y over x is equal to 1. So therefore y is equal to x. Perfect. So wherever I see a y, I can substitute an x, or vice versa. So here we go. We're going to use this equation and these two equations, and that will help us solve for x. So let's do that. We've got 9 times dt. dt is 30 minus x squared plus 15 minus y. But remember, y is equal to x, so I can just put in x squared. That's dt squared. And that equals 25 times dj squared. Well, dj squared is up here, this guy. And that's going to be 15 minus x squared plus 15 minus x, remember, because y is equal to x. And there we go. This will allow us to solve for x. And I think we can probably solve for x without any quadratics, as long as you don't expand it. So don't be in a rush to expand it. So let's see here. What am I doing first? Well, just multiply the 9. That should be good enough. So 9 times 30 minus x all squared plus 9 times 15 minus x all squared. On this side, it looks like 25 times 15 minus x all squared plus 25 times 15 minus x all squared, like that. So this is 50 15 minus x all squared. And then we can bring this guy over, since that's pretty much like a like term. And then this just becomes 9 times 30 minus x all squared. These two all combine, so that gives me just 41 15 minus x all squared. And this is 9 times 30 minus x squared, like that. Okay? Now at this point, take the square root of both sides. If you do, this becomes 3. This just becomes 30 minus x. Correct? And then if you take the square root here, you get the square root of 41, and this just becomes 15 minus x. So good news is we didn't have to use a quadratic. Now we can expand. This becomes 90 minus 3x, and the square root of 41 times 15 is approximately 96. So I'm going to put a little approximate. And then the square root of 41 times x is approximately 6.4, like that. Okay? So if you bring this all over, this looks like it'll be 6, and this will be about 3.4 approximately. And solving, you get x is equal to 1.76. Okay? So this is all approximate. So we've figured out x, which is this value right here. Now the question wants you to figure out the time that it takes Tom to catch Jerry. So essentially the time it takes Tom to go from there to there. Okay, no problem. That will require this formula right here. Right there. Time is equal to dt over st. St is pretty straightforward. That we know is just 5. And dt we can figure out with this formula right here, because we figured out x, and x is equal to y. All right? So let's do that. Time for Tom is equal to his distance divided by his speed. And we know his distance is that big long formula, and his speed is 5. So I'm going to calculate dt over here. dt, if you remember, was dt squared was 30 minus x all squared plus 15 minus y all squared. Correct? Well, x we just figured out was 1.76. So 30 minus 1.76 all squared plus 15 minus y. Well, y is equal to x. Remember, we calculated that through similar triangles. And therefore, I can just put in the value for x here, 1.76 all squared. All right? And if you do the math, you'll get approximately 797.23 plus 175.17, and that will be dt squared. And therefore, if you take the square root of this, you will get approximately 31.18. All right, so I plug that back into here, and I've got time is 31.18 divided by 5, and that is approximately 6.236 is the amount of time it takes Tom to catch Jerry. 6.236, and let's see here. That would mean closest to 6.2. So number 23, the answer is E. If a plus b are positive integers such that 1 over a plus 1 over 2a plus 1 over 3a is equal to 1 over b squared minus 2b, then the smallest possible value of a plus b is. So let's first add the fraction and see if that helps us in any way, and we will proceed from there, keeping in mind that a and b are positive integers. So getting a common denominator probably is 6a, so that means top and bottom by 6 here, top and bottom by 3, and top and bottom by 2. So that gives me 6 plus 3 plus 2. And this is the same, 1 over b squared minus 2b. So that essentially just becomes 11 over 6a is equal to 1 over b squared minus 2b. Cross multiply and you will get 6a on this side, and on that side 11 times b squared minus 2b. 6a, 11, I'll factor this, b, and then b minus 2, like that. All right? So that's about as far as I can go. Now, we have two variables, we only have one equation. So therefore, this is going to be solved by inspection, right? You need two variables. You need two equations if you have two variables to solve, but we only have one equation. All right, no problem. Let's do this using inspection. So this is my equation, and the only thing I know is that a and b are positive integers. All right, the only way this can work is if this right here, a, is a multiple of 11. Why? Because look at the other side. The other side is a multiple of 11. It's 11 times b minus 2. So this also has to be a multiple of 11 for these to give integer solutions. So that means a must be a multiple of 11. So let's work with that. Let's try. First, we'll try 11 itself. Here we go. 6 times 11 on that side. 11 times b minus 2. Correct? So the 11's cancel, and I'm left with 6 is equal to b times b minus 2. b and b minus 2 are obviously two integers that differ by 2, right? So for example, 4 and 2 or 6 and 8, like that. Can you have two integers that differ by 2 multiplied together to give 6? Well, 3 times 2 equals 6, but 3 and 2 do not differ by 2, they differ by 1. So this is not possible. All right, no problem. Let's go to the next one. Let's try another multiple of 11, 22. So that gives me 6 times 22 is equal to 11 times, again, same thing, b times b minus 2, like that. So this gives me the following. If you bring all the numbers on one side, this will just become 12, and that is b times b minus 2. So the same type of question, do I have two numbers, two positive integers that differ by 2, when multiplied together give me 12? Well, let's see. 3 times 4 gives me 12, but those two integers only differ by 1. 6 times 2 gives me 12, but those two integers differ by 4. So unfortunately, no way for this to work if a and b are positive integers. That's wrong. Let's keep going here. A equals 33. Let's try that. 6 times 33 is equal to 11 times b minus 2, same thing. And if you take care of all the numbers, this becomes 6 times 3, which is 18. A is equal to b times b minus 2. Same question. Can you find two positive integers that when multiplied together equal 18, but those two integers have to differ by 2? Well, 3 and 6 give me 18, but those differ by 3. 9 and 2, but those differ by 7. unfortunately, that doesn't work either. Okay, no problem. Let's try a equals 44. Sooner or later, we're going to have to get the answer, right? 6 times 44 this time is equal to 11 times b minus 2. Taking care of the numbers, this just becomes 6 times 4, which is 24. Now, you tell me, can you find two numbers that differ by 2 when multiplied together give 24? And the answer is yes. Those two numbers are 4 and 6, right? 4 times 6 is 24, and 4 and 6 differ by 2. So that basically means that b is equal to 6, and this b minus 2 is equal to 4. There you go. You just got it. B equals 6, A equals 44. And they wanted us to find A plus B, so therefore A plus B will be 44 plus 6, which is 50. Let's go back and remind ourselves, yep, A plus B is what they wanted us to figure out. We had figured out that A was 44 and that B was 6, and therefore A plus B is equal to 50. So the answer to number 24 is E. Three identical cones each have a radius of 50 and a height of 120. The cones are placed so that their circular bases are touching each other. A sphere is placed so that it rests in the space created by the three cones as shown. If the top of the sphere is level with the tops of the cones, then the radius of the sphere is closest to. This diagram illustrates the cones if you're looking at this from the perspective of just their bases, the circular part of the cone. And you'll notice, of course, that they touch each other. And what I'm going to draw is the centers of these circles, and then I'm going to connect them like that. And these circles are all identical, and therefore the distance from the centers are also identical, because this is the radius, and so on, right? So this is an equilateral triangle, and that represents the center of this diagram. Now, one thing that's important to understand is that when you place this sphere in that position, the center of the sphere will line up exactly with the center of this equilateral triangle. And what is the center of an equilateral triangle? Well, it is known as a centroid. And now I'm going to draw the diagram to illustrate what is the centroid, and we then have to figure out the distance from the vertex to that centroid. So here is our equilateral triangle, and the first thing I'm going to do is draw lines from the vertex to the opposite sides, like that. And the centroid is this point right here, that one that I just drew the red dot. And we have to figure out the length of this segment from the vertex to the centroid. So how do we do that? Well, one thing we know that this is most likely a 30, 60, 90 triangle. This is, of course, a right angle. This whole angle was 60 because it's an equilateral triangle. So if I cut it in half, this angle is 30. And therefore, since this angle must be 90 minus 30, it's 60. So it is indeed a 30, 60, 90 triangle. And if I draw that triangle over here, I will be able to illustrate what the distance is from here to here. Well, we know that from here to here is the radius of the cone, and they told us in the question stem that that is equal to 50. So this is 50 in terms of a numerical value. But because we know that in a 30, 60, 90 triangle, the ratio of the sides are 1, 2, and root 3, we can now figure out this side. That side, if I call it x and use the ratios, x over 50 is equal to 2 over root 3. So therefore x is equal to 100 over root 3. So that represents the distance from the vertex of the triangle to the centroid. And that is going to help us later in the question. So now I have to bring in the sphere. So far we've just been discussing the 3 cones. But remember, there's a sphere that has been placed. And now we have to try to figure out the radius of that sphere. So this diagram shows you how that sphere has been placed. Now I have to draw it in 2D and try to figure out the radius of that sphere. So here is my 2D representation. This is the cone, this is the sphere. I'll call this point A. I'll call this point B right here. And then we'll call this, of course, the radius, big R. This is also a radius of the sphere, big R. And this point that is tangent, I'll just call that C. And then top to bottom, this green line represents the height, which is the same as the height of the cone. And if you remember, that height is equal to 120. They give you that in the question stem. All right, now this from there to there represents the radius of the cone. And if you remember, that was 50. Now we come to the point of the question where this value comes in. Remember, 100 over root 3 was the distance from the vertex to the centroid, right here. The distance from the vertex to the centroid. And if you remember, the sphere will align with the centroid, the center of that sphere will align perfectly with the centroid. And therefore, since this is the sphere, this is the centroid right there. And this is the center of this sphere. Those two will be aligned. They'll be right in the same line top to bottom. And this, of course, represents this point, the center of the cone, the circle part of the cone. So therefore, from here to here is essentially the distance from the vertex of that triangle to the centroid. Let me show you in this diagram. This is the center of that cone. This is also the vertex of that triangle. And if you draw a line from the vertex right here to the centroid right here, that represents this distance from here to here. And I think that is probably the most challenging part about this question. So that distance is 100 over root 3. Okay? Now 100 over root 3 is approximately 57.73. So therefore, this distance from here to here has got to be 57.73 minus 50. So this is approximately 7.73. The distance from there to there. Okay? Now, one important point that needs to be mentioned in this question before I move forward is that you've got two tangents. One is from A to C, right there. That C point is tangent to the circle. And the other one is from A to B. That point B is tangent to the circle. And because AB and AC are both tangent to the sphere, it's really the sphere that we are talking about. AB will be equal to AC. And that is something that we will need to use a little bit later in the question. So now we have to figure out R. So what I would like to do is draw a line from the center of the sphere down to this point right here. And the reason is that's going to help me figure out R. And I will label that distance y. Okay? And then this is, of course, a tangent point, C, so that means that is a right angle. And this is a perpendicular that we had drawn earlier, so that is a right angle. So now, this will be two Pythagorean relationships. So the first one involves this triangle right here. And that will give me the following equation. Y squared is equal to 7.73 squared plus this distance. Well, that distance is the full top to bottom, which is h, minus this radius, minus r, like that, all squared. And that gives me y squared is equal to 59.83 plus h is 120, so it's 120 minus r, all squared. So that's the first equation. The next equation will come from this right triangle right here. And that one will give me y squared is equal to r squared plus this distance right here. And I can call this point D, and therefore we can just call that CD. But what's CD? It will help if I knew the numerical value for CD. That way I can just set these two equations equal to each other and solve for R, and we'll be done. So how do we figure out CD? That's the second last step to this question. Well, let's figure that out. First, we will need to figure out the distance from A to D, that whole distance. And that can be done using Pythagoras, once again, using this triangle. Using that triangle, we have h squared plus this small r squared is equal to AD squared. H, of course, was 120. Small r was 50. And then we have AD squared. Solving, we get AD is equal to 130. All right, so we've got part of that. Now we also know that AC is equal to AB. We figured that out earlier right here. So AD minus AC would give me the numerical value for CD, like that. AD we just figured out was 130. AC is the same as AB, and AB, we know, is from here to here, which is the same as here to here, which is 100 over root 3. So 130 minus AB, which is equal to 100 over root 3, which is 57.73, is equal to CD. So therefore, the numerical value for CD is approximately 72.26. And there we go. We can put that back into this equation, and we'll get y squared equals large r squared, which is the radius of the sphere, plus 72.26 squared. And now we can set this equal to that and solve for r. So 59.83 plus 120 minus r all squared is equal to r squared plus 72.26 all squared. And this will help us solve for the radius of the sphere. So here we go. This becomes 59.83 plus 14400 minus 240r plus r squared is equal to r squared plus 5222.2. The r squareds cancel, and I'm going to put the 240r on this side. And all of these numbers, when combined, give you a value of 9237.63 approximately. And solving for r, you will get a value of 38.49. And this is the numerical value of the radius of the sphere, 38.49. Let's go back and see what are the answer choices. 38.49 is closest to answer D for number 25.